we are talking about files. If you basically create, I'll just repeat that once again and sort of show you a little deeper picture of why databases and what kind of things that happen with databases, and um, do that application, which I was actually showing you that application again. Show that once again, and then lay out the roadmap, how the concepts will come, how I use that application to sort of enforce those concepts again. Okay. Right. That's a kind of thing that I wanted to do. Just to give an example, last time I think we were talking. Let me just share the desktop. Um, I'm in the sharing mode. Let me start. We were looking at how we will sort of use the files. So I just thought of putting some uh, um, how will I write my programs, to start with. For example, let us say I'm talking about the banking program. This is, I'm on a single machine. I'm on a Linux Mac operating system, which is more or less similar to the Unix operating system, right? So in this, let us say we are creating files. Okay, for example, I've created, to start with, a master. I'm actually trying to do the uh, you know, banking example, let us say. Then what will I do? Actually, I'll create a file called bank master. Okay. And then in this bank master, what will I do? I'll actually, I think I'll store the, okay, this is a file, just simple file I'm creating. Okay. This is a file, nothing else but a file. I'll say Prashanti. Okay. Um, then her bank balance is, let us say, 1,000 rupees. This is what I'll do. Then I think there is Prabhakar. I think these are all the names remember since last class. Okay. Let us say he has 2,000 rupees in his bank balance. Then Ramya, okay, and she has about, let's say again, 1,000 rupees. Okay. So these are the three students, and their names are created. Bank balance is created. Okay. This is a simple file, Unix file. When I save file, this file name is bank master, and I just say access and then save this file, and then so this is basically a simple file that I've created to store this information. Okay, this is the information that I have: a student name and the corresponding bank balance that he's having. This is like a ledger entry. If I had actually got a physical paper, I would have stored this information. Prashanti 1,000 rupees, Prabhakar 2,000 rupees, Ramya 1,000 rupees. Okay. Now this file, where is this file? This file is actually a Unix file. In this particular case, a Mac file called bank master. And then if you look at the print working directory, this is in this /user/djram in this directory. Okay. In this directory, there is a file that got created, and there is a data that I had put into this file. Okay. Now, given when you create a file, what we are talking is you can store anything into this file. Now I've stored this Prashanti, all this information I've stored in this particular format that I am actually looking at. This is a specific format that I have created. For example, somebody else can put a colon or dot or whatever it is between the bank balance and this. So it depends on the person creating this file. What is the format in which has put this data? Okay. And where is this file stored? This is stored on the hard disk of the system. See, there is a disk. The disk has the operating system running, and it has a file system associated with this operating system. And the file system is identified in this particular case by a what is called two different spaces. One is a namespace where the name of the file will come, and actually the blocks where the data is actually stored. Okay, so there is the file system format. Okay, there is a file name and the corresponding blocks where the data of that file is available is all in the hard disk of the of this computer system. Okay. Now, when I access this file, bank master, this file is basically from the disk. It is read into the possibly there are various layers involved in this process of picking the file data from the disk, reading a block, moving that block data into the memory, and then correspondingly displaying this. So if you're actually accessing this file data, as I've done in this particular case, there are driver programs which go pick the data blocks of this particular file and then display it to me. Okay. This is how the file system will work. Now, if you've written a program, for example, you want to write a C program that manipulates this file, it will actually look something like this. Uh, this is the kind of program that you will see. Okay. Let me see if I'm actually able to go back to the A view also. Okay. Are you able to get me the chat going on there? Increase the letter size. Okay. Um, yes. So there is. I have to do the part. Let me see if I can increase the font size here. So it's actually escape here. Control X, Control X. Okay. I think the okay, something like this. Okay. Now this is a program that actually uses that file. For example, in this particular case, you can see that I've just written a small program to manipulate the balance. For example, here, this C program will open this file, and as you can see here, it will actually read from this file. This is the place where it will read the file, and it will try to update the balance, and it will write the information back to the file. So I'll write my C programs manipulating these files. Okay. You can write similar programs. You've already should have done this. I'm not sure what extent you have done it. That's why I'm just showing, some simple sample programs to show how exactly I would have done if I don't have a database system, and what I will do if I have a database system. Just bring that difference. Okay. Now, when you run this program, okay, now you can compile this program. For example, you can, no, I won't actually, this is a C program, right? So I've written this C program. Now this C program will, go and remember this C program also is tied up with the format, the way. For example, the format is the name and the, so when whoever is writing this program is aware the way the information is stored in the program. For example, this is the way the information is stored, the name and the balance. If it is the other way, he has to correspondingly change this program. This program is tied up with the file format. The way you've written the file, you understand that, how the information is stored in the file, and this program is written keeping that structure in mind and written this. So what is the file format or model, that is model of the data that is stored in the file? I have actually created that model. In this particular case, name and balance. That's what I created. And then this program is written keeping that in mind. Okay. This is what you will do normally. If then you can actually do the GCC on this, and then I won't do all that because that's not required. So once you actually do the compile this program, you get the A dot out, and then you will run this program A dot out to actually manipulate this. That should read the all these three entries, and then the balance should be whatever balance you have, it should be reduced by so much, and you write that balance back onto the file. Okay, this is how people write programs with files. Okay, now when you're running this program, let us say this is the program, you compile this program. This actually is a no, not the 3 warnings in this doesn't matter. Okay, if I run this program, this will be, for example, for running this program, this would have actually stored it as an a.out file. So I basically have to run the a.out. I won't do all that. Basically, it will run this program. This is the program that is running. Where is this program now? This running program is actually in the memory. This is a process. So there is a process that is running, and that process has now opened the. What is important is for you to understand is, now look at what is the this bank program dot C would have. So this is the program. Okay. Now when I come to this point, this is opening the file, whatever file that I've created. This is opened in a write format for me, and this is the file pointer. This file pointer is nothing but a pointer in the memory where there is a this is a variable, as you can see, and this is actually associated with a buffer. Now when you do this fscanf, there will be a driver integrated to this which will go read this file which is on the disk. This data is now in the disk, and from the disk it will be brought into the main memory of this program. Now here is the point where the data will be read from the file pointer, as you can see here. This is the cache associated with that, and that will be transferred to the memory space. Of balance is written back, name and balance is written back onto the file again, back to the file here again. Okay, so now you can see there are several layers involved: reading the data from the file into the program, manipulating the data in your program, and writing this information back onto the file. Okay, the file is in the hard disk. You should remember that the file is in the hard disk. Okay, and the program is running in the main memory. Okay, now there are several, what we were saying is there can be several things that can happen when you are dealing with ordinary files like this. Now a simple thing that can happen is, while I'm running this program, the power can go off. If the power has gone back, the file, here is a file that is open now. Okay, there is some data. Now what data has been written onto the hard disk of the file which is resident on the hard disk, you will not have any control on that particular part. It is possible that your bank master file goes off, so you may not be able to recover this bank master in the event of a failure. Okay, that's first problem that we were talking about. There are several layers here. You should understand, when the data is being transferred from the disk into the main memory, there are several programs involved in this, several layers involved in it. When all these are working, you still don't want your data to be lost. That's the key thing in some of this. For example, if this bank master data is lost, then it's a permanent loss of information for you. You don't want that loss of information for you. As far as now, let us say this is the okay. Now I can say that I'll open one more. Let us say I will sort of get to a point where I will say that I will open one more terminal here. Okay, so if you basically can then say, now I will start one more terminal here. Now I'm not actually starting, so I'm just starting a new window now. There's one more window here, as you can see. Right now, if I say, I also want to say this program dot C, the bank program, right? This is the program that I have. You can see there are two this where this file is open now. There's one terminal, one person is working on it. Now I also open this same program. Now if I make some changes to this program, let us say I want to make this as comment. Okay, now if I actually save this, okay, this is written now. Okay, now say that I actually exit from this. Okay, now this process is completed. Okay, now I can switch back to the other process if you want. Now I'm here. Okay, now let us say I save this file now, and then now I want to see what was saved in the bank program. Now let us see if the now the there are two edits which got saved. There is something else which I am doing. Okay? For example, if I deleted that one line, how this whole thing will work, both these changes will work on the file, I may not have any control on that, right? So typically simple files don't support multiple people opening the file, two programs simultaneously opening the bank master. For example, here is the bank master. Okay, that we are seeing. Okay. Now let us say two programs are opening and reading Prashanti's balance of 1,000 rupees at the same time. Okay, and each one changes, 50 rupees, 60 rupees. Now when it gets saved, you never know now what's going to happen to this balance. Which one will write first and what will happen to the balance that is being written back? You will not have any control. So simple files, when you want to use simple files and simple C programs to develop these kind of applications, you will run into a lot of difficulties, and that's a place where you can't actually use C programs and files for developing the business applications, where common business applications, where you need much more no, facilities on top of the file system. Okay, that's what basically are called database systems. What the database systems provide you is an ability to store this data, retrieve data, and when multiple people are working on it, an ability to actually make sure that consistency is, this kind of fault tolerance, consistency, all these are actually inbuilt into this database management system. So when you use a database management system, you are actually wrapping your file system with all these extra management capabilities that are provided for you, so that you don't run into problems such as just explained with the file system. That's the idea of using the file database systems instead of simple file systems. That's where we move from using file systems to database management systems. Okay, this is the first thing that I would like you to actually understand. Okay, let me see if there are any questions on this. I'll also close this with the same user log. Krishna, hello, Ramakrishna. Yes. See, it logged me out saying that some other user logged in a particular IP, another IP with the same user ID, somebody logged in. At what time was I cut off?
हाँ सर.
Hello? At what time I was cut off? It says that another user with the same User ID has logged in and then it disconnected my system.
No, sir. I will check it out. Logs. I will check the log, sir. Just 5 minutes, 2 minutes back only you are logged out, sir. Just I will check the logins, logs, sir.
When did I get cut off now? I was just doing that file system and this thing. Where was, at what point I was cut off now?
Second, sir.
At what time, how the file will be read by the program and why we need database systems. All that came to the people, or I was cut off even earlier than that. At what point my video just went off? Hello? Up to the file system thing, what exactly can somebody, okay, I'll just see if I've gone into any questions on what I've actually covered. I was just covering um, files and database differences. So I actually opened a file, a physical file on my system, and was showing how the data will be stored and how the program will read that data, and then how it will come to the memory and what kind of problems will come if there is any power failures or any other issues like concurrency on full programs operating on the same file. That's what exactly I've covered in the last 15-20 minutes. Are there any questions on that? So simple file systems, we can't develop banking kind of applications using simple C programs and files. It won't work. You need the files to be provided with lot more management facility. Okay. Uh, you need to provide a lot more management facility on top of the files, and that's what we are calling as a database management systems, DBMS. Okay, the database management systems have several layers now. First part is the data. Okay, now as you can see in the hello, am I audible now? Am I getting? Are people receiving now? Monitoring me regularly is the see, last time I was got cut off and then I didn't know that I was got cut off and I was just doing something. So please, if you're doing the live monitoring, I guess you're doing live monitoring, please call me on my mobile number the minute I'm actually cut off from the system. Okay, right? Okay. Okay, so yeah, so there are several layers that are part of this database management system. The lowest layer is the data, which is the file, the equivalent of a file. Okay. Now let me share the desktop and show you how we would have transferred this to the database management system. What we are doing, how this would have got translated into a database management. Uh, okay, something like this. If you're looking at numbers, I'm just giving some kind of a data model. This is like the table kind of thing that would have been there. This is the first thing is the data comes with the balance, and here this is where we will now put Prashanti. Okay, and then balance of 1000 rupees. Now this is a model. This is the model, okay? And then we will say Prabhakar, and then we will say 2000. This is only you can create now a field, and then a corresponding, these are basically columns. As you can see, each column is associated with a particular field, and there is each row. There are 2 rows here. Now we actually, our file there has 3 rows, right? So now this becomes 3000. Whatever we had there as a file now got translated into this data model. This data model is a tabular model. They're basically columns and rows. Now these are the 2 columns, name and balance. Then it has actually these rows: Prashanti, Prabhakar, Ramya. Okay, something like this. Okay, I think these are the student names from JNTU Vijayanagar. Okay, this is the data. First level data comes. The file comes with a particular model, data model. This is one data model. Okay. Now, last time what we were discussing is what are the different kinds of data models. Okay. Now, can everything be represented in a model that is more tabular? That means you'll have columns and rows. Can I represent all kinds of data in the form of a table? Okay. And what are the cases where representing the data in a tabular form will be very difficult? For example, it's very easy to represent, for example, the student and his marks. Okay, here I have represented the name and the bank balance. Okay, the student, the course, and the marks, that can be easily represented again in a table format. Lot of common business applications, the data actually can be represented by a tabular format. Okay, and this more formally is called, these tables are called actually relational model. Each of this is called a relation. Okay, in mathematical terms, each of this is called a relation. Okay, and further we'll go deeper and study this. It is actually called the first order, relational calculus or relational algebra. Okay, and then this representation is the mathematical form of representing the data in this particular model. Okay, now this is also called, for this reason, if the data that is supported, data model supported by the database management system is relational model, then it is called relational database management system. Okay, since a large number of common business applications, it is possible to represent the data in simple tables like this. It is actually the de facto model as far as databases is concerned for a very long time now. It's changing now with unstructured data. This model is being now questioned. So this model is evolving now for the big data context. As the data is becoming unstructured, more and more unstructured data is getting represented now. This data model is being seen as having difficulties in capturing that kind of data. But a large number of common business applications can be represented in this table format, as I've just shown you here. Okay. Now, first thing is the data model. Data model is a relational model. The question that we were asking last class is, can all data be represented using the relational model? The answer is no. For example, if you are representing, for example, in this case, let us say I'm representing the parts of a car, this thing. Okay. Now, you will say part ID. Okay. Now, question possibly, if you're trying to look at Maruti car and want to capture all the data that is present in the car into a kind of a model, we are not sure how that can be captured. Okay. Um, there are various issues here. For example, if you want to say one of the fields here, part ID and then part configuration, you want to say this. Okay. Now, there is a subpart here. Part ID is 101, and this is basically the configuration is, let us say, chassis or something, and then this has a subpart associated with this. Now if I say here there is a subpart here, okay, then I need to link up this subpart into this. For example, I have to say now 202 or something like that, and again I have to put this 202 here, okay, and then say that chassis, front or something like this, and again put some 303 to capture something else, then 303 will come here. Now when I'm accessing 101, I should be navigating through this to figure out the table is not a simple flat table as it is here. The data that is there in this is again related to something here, that is again related to something. The rows, the represented rows have a kind of a relation, and largely you might actually want to navigate with this into this data. For example, you want to first access 202 and then go to 101 to 202 to 303 like this. You want to navigate through this data. Okay. Another simple example could be an employee and a manager. Okay. For example, if you're trying to do an employee and a manager, and each time an employee has a manager, his manager, his manager, his manager, typically you are capturing the information in such a way that you would like to navigate through this data. Okay. The other kind of a problem could be, for example, you want to put all of this information as part of the, for example, for the car, let us say, you want to put all the data that is available here into one single, okay. For example, you have several models of Maruti, let us say, okay. And then we will just say, I want to represent that data into this data model here, okay. So what will I do now? I basically will put Maruti model, okay, which let us say is 800 cc or something here. This is a now all the stuff that is part of 800 cc, let us say I want to capture here, okay, all the, there will be several now, part 1, part 2, like that. There are, let us say there are 1,000 parts in this. So I will actually have to now do a 1,000 part thing here. This will go, the number of columns will be 1,000, and how many models will be there for in Maruti 800 cc? There are 5 or 6, probably there will be 5 or 6 rows, and there will be a few thousand columns. Now you can see this data is so much different from the data I'm having here. This is actually tall and skinny. This is fat and fat and small. Basically, somebody is very fat and small. This is the kind of model that you get here. In this particular case, it is the tall and skinny. Okay, this number of rows will be few million. Yeah, there will be few million bank accounts, but then the number of rows will be maybe 10 or 20, depending on what's there. So there is this data in terms of the table, capturing the data into tables, okay, is more appropriate when you have this particular model. Okay, that is the data model. Typically, this is what is called the data model. In fact, we will see as we go along the concept of an object associated with this. You can also have a concept of an object, and we will understand the object databases, object model databases, how this each of these tuples here, for example, can be converted into an object. Okay, not just as it's going to be a row, but this itself will become an object. So there are several forms of data models that are possible when you're dealing with database management systems. So what is the first important part of the data, converting a file system into a database management system? You need to first have a data model. The file will only store, now if you decide that the files are going to be tables, then this is the only data model that will be supported by your database system. Popularly, this database system is also called relational database systems, RDBMS. Okay, to a large extent in this course we will only study relational database management systems. Okay, So once the data model, the files here in the underneath data model of your file system is relations, then the files become, at the data level, they become relational database management systems. Now, once you've got the files, the second part of it is the management systems. Then you have to provide a wrapper that manages retrieval of this data and manipulation of this data and storing things back. Okay. Are there any questions on the data model part? Anyone is having a question on the data model part? Am I still there or not there? Am I on? Yes. So are there any questions on the data model part? As what we are trying to, at the first level, what we are trying to, this is still the introductory class. Okay. I'm still at the introductory class. I'm trying to make the bigger picture for you as I'm going. Okay. So what I'm trying to get for you right now is how a file system, traditional file system in an operating system, becomes a database management system. Okay, that is what I'm trying to capture for you now. Okay, the reason why I'm doing this is I found with the questions I asked, this was not very clear for you. So first difference that should be clear for you is a file is a raw file. It doesn't have any model associated with it. I can just take a file and store whatever I want into it. I can, for example, I opened a file bank master. I can store a leave letter. I can store anything, and that will be taken and stored in the hard disk. And the programs that are actually reading this data have to retrieve it and manipulate the way they want to manipulate it. So the first thing that will happen in database management system is the data model will become part of the system. For example, what we saw as a set of columns and rows. This is called the table. Okay. In some sense, each table mathematical form is called the relation, which we will study later. Okay. Now this becomes your standard data model, which means that instead of getting relational database management systems will support relational data model. Okay. Now that's a data model. RDBMS means relational database management system. There also a layer on top which will come in a minute, which will give you the support for managing this relational model. Okay. Just providing the model is not enough. It should be also be provided with the management capabilities. What are the management capabilities that we are talking about? The management capabilities are when the power goes off, for example, the state of the data. Okay, so the logs that should be maintained and made sure that data is not lost. Okay, when two people are accessing this data simultaneously, there need to be consistency of the data. All this will be provided by the management system. So when you say relational data model, you are talking about how the data can be stored in the system. Okay, the data can be stored only as tables, as relations. Okay, now when you talk about relational database management system, along with this model, you get all the capabilities of managing this data. As I said, fault tolerance, consistency, all these are provided as part of the management system that comes with it. So relational database management system is a package, complete package, which supports storing thing. For example, if you buy a white notebook, there is no model associated with it. That's what the file systems will support. You can write anything on the white page. Okay, if you buy a white page notebook. On the other hand, if you buy a ledger kind of a notebook, then you can put the column headings, and then along that you can write the rows. The rows can be entered. So this is the, when you say I have a relational model, you are actually getting, this is the only way you will be able to store your data as relations. That's basically the tabular data. That's what you will be able to store in your system. Okay, that's the first difference that I want you to understand between the file system and the database management system. Okay. Any other questions people have on this? You can put it on the chat. There's no problem. Okay. If any other questions are there, please put it on the chat and I will sort of answer. Okay. I'm just redoing a little bit of it after my interaction with the students. I thought that I should give more examples to make sure they understand when we are trying to use this relational model for storing a variety of data. Okay, right? This is the first thing. Okay, so let us move on. Now, okay, for an interaction with them and see who is the person who is asking the question on. Okay, I'm just going there now. Can I get the person who is asking this question, please? Hello? Hello? Is JNTU publishing its video? Hello? Who is a, no, I just want to actually have a small interaction. Our image is stored in the, that's a question that was asked. Yes. Why there are so less students in this, in the what happened to JNTU Kakinada? Who is the person asking this question? Can you just, why I'm not getting to the full screen here? Yeah. Yes. I'm seeing very few students here. Murthy, why am I seeing so less students here? What happened to the students today? Who was asking this question? Can you just no, tell me your name and then ask the question? I'm still not getting the question. Who's the person who's, I'm not getting the audio. Can I get the audio? Okay, let me explain. Yeah, it seems to be getting the audio and then lost again. Yeah, I see some students, but their faces are they actually sleeping? No. Now I am seeing more students. I think their faces seems to be. Are they watching like a film? See, if not anything else, they're getting good sleep in the classroom, is it? No, I think good that you have asked a question. So I want to actually catch the person who asked me that question. It's nice that you have asked the question. Who is the person? Yeah. Actually, you're cut off now. Can you just, yeah. Hello? Yeah.
Good afternoon, sir. This is Likita, sir.
Nikita. Hello?
Good afternoon, sir. This is Likita, sir.
Good afternoon, Nikita. Yeah, yeah. See, is that your question is how do we store images, right?
Yes.
See, if there is a JPEG file, you can just take it to the, for example, I just showed you the two columns, right? In this column, let us say you will put it as a photo, okay? And then you will put a JPG file of Nikita, right? Nikita.jpg, okay? You can store it. A file can be stored into this. That's not the problem. The problem is, how do we manipulate this field? Okay, so that becomes a problem. For example, you want to find out, if Nikita is wearing, red, chudidar, okay, right? Or I want to get all the students who are wearing red chudidar in this class, okay. Then will that be possible? That kind of question can I ask? That will be the problem. The problem with image databases is not just storing the images. You can just store the images, but you want to ask some questions on about these images. For example, you want to get all the places where Sachin Tendulkar scored a 6. You can have a video database, but then finding that and retrieving that will be difficult. But then I can suddenly ask the question, get me all the students who have scored more than 90 marks in my Dbms course. This will be easily processed by this model, right? Okay. It's easy to actually take this, ask this question. If everything can be, for example, in this case, if there are a lot of users, I can ask a question which can be processed by them. Okay. Now the question is not about storing the data. Storing the data is just simple. In the column, in the column fashion, you can give an ID and then store whatever you want. But only thing is, what do you want to manipulate? When you want to manipulate that data, some cases it is not possible. That's where it becomes, these databases become image databases, okay? They become video databases. In the case of YouTube, they become video databases. But then, you can't really do much except storing the data and just retrieving it completely. Nothing else is possible when you get these databases, and that's what people are working now. That's the new forms of database that people are working on. Okay, right now that's again out of scope of this particular class. For example, image databases, video databases, multimedia databases, all these are out of scope of this particular class, okay, course, okay. But you have to study them separately as you go along. But that's a very good question in the sense that these are all things that people are working now, okay, right? Okay. Excellent. I think now I'm seeing a lot more heads of the students, so they are there. Only thing is they're all hiding, probably they are relaxing and then seeing the picture there. I think afternoon classes are good classes for sleeping, right? If not anything else, I'm worried about teaching this afternoon class in my IIT Madras also, because one of the key things is we have to keep you alive, keep you awake, okay, right? Both are important for us, so that becomes a very important thing. Any other question people have before I actually branch off? Are there any data model part? The data model part, we'll still go deeper into it. We're just trying to create the background and make you a little bit aware of what is the difference between file system and database system in this lecture. Okay, I'm slightly doing it in a different way to make it more clearer for you. Okay, is that clear now? If there are any other questions from the other colleges, please raise them now in the chat box for me. Okay, I'm giving a couple of more minutes for people to think and ask a question. If you don't ask a question, I will be disappointed. Okay, I'll consider that you're sleeping. Still no questions. Okay, then I'll ask one question. Okay, I will pose a question back to you, which I've asked last time. Okay, how will I store, for example, Flipkart data? You all know Flipkart, right? how will no Flipkart data, for example, there are merchants and there are sellers. Okay, the merchants trying to sell things, there are buyers who are trying to buy the stuff. Okay, now I what kind of data is this, and then how do I actually store, for example, you know what is the kind of data? Can graphs be stored into simple tables? Can graph, uh, how to connect the application to the backend manager? Somebody is asking this question: how to connect the application to backend manager? Okay, who is this college? Is this college? Can I get this college, please? Um, yeah, I think this is Usha Rama College. So I'm just going to go to that college. Where is this college? NG, yes. Okay. Let me go there. The selected user is not publishing the. Is he publishing or not publishing? Who is the person asking the backend this thing? Okay, I think they are not publishing. See, Usharam, are you publishing your your video for me? Otherwise, please identify the student who asked this question for me. Can you identify the student name? I'm not getting the response, but hope they're listening to me. Their question is how to connect the application to the backend manager. Please remember, so far whatever I've covered, there is no backend and there is no front end. Everything is on the same machine. Okay, right? If you have understood what I am trying to tell you, there is a C program running on the same machine. There is a file which is stored on the disk on the same machine. The C program is accessing the no, data on the disk. Okay, and those what kind of a problems that will come when you write this application accessing the disk data. So the user would have connected and running this application on the same machine. Okay. Student name is Sahitya. Sahitya, actually, if you understand what I am talking, everything is in the same machine now. There is no back end and there is no front end. If you take the front end as an application that gets connected to the back end system, and the back end is running the process. There is a program that is running in the back end. Okay, and that back end program is accessing the data. Now the question is, if the data is stored in the file system in a simple file, then all these problems will come. If the program is accessing a database management system, not a file, but the data stored in a database management system, then these problems, what we are talking, will not come. That's where we are now looking at. Okay, is that clear? This is file system versus database management system. Okay, and what we were discussing now is files will not have any data model. Now we will have a relational model. Okay, relational model means essentially the table model. That's where we are right now. Okay, now the next question is the data access. Hello? Yeah? Yeah. Can I just call you back? Yeah, I'll just call you. Yeah, so yes, so the second aspect is, given this data, how are we going to access this data? Okay, now that now the data is already stored, let us say in the now the database model. So the model is there. I've stored all my data using this data model. Now how do I actually access? What kind of access that I will do with this data? That's the first question. The second question is all these other management issues. For example, what is the concurrency? If multiple people access this data simultaneously, what is going to happen? If power goes off, what is going to happen to this data? All this become the management issues. Before we get into the management issues, along with the data model, the access model also becomes important. So we have a data model and there's a corresponding access model. Okay. Now, what is the kind of access model that we generally talk about in the relational databases? These are actually called, generally what we do is a set oriented is we generally will ask the questions such as, given this table, give me all the all the rows where some criteria is satisfied. For example, we'll go back to this model that we are actually showing you earlier. Okay, and I think I have that. Sorry, I think I have possibly the. Did I actually? Yes, this is the one which I'm using. Okay, this I will remove this. This is, let us say I have, instead of this I have basically, instead of students, name and then marks. That's what I have, and then I'll make it for Prashanti I'll give her 95. For this guy I will give 65. I have two daughters, so I actually like girl students, so I'll give them 90 marks. Nothing against boys, but they are also good, but then all of them are scoring above 60. Okay, now let us say I have a few thousand students like this. What is the kind of question I'll ask? Get me all the students who have marks above 60. Okay, then all these people will be retrieved. Okay, now generally in the tables we will ask the question. This is called actually set oriented queries. So basically this is considered as a set now. What is the elements in this set? This Prashanti with 95, Prabhakar 65, Ramya 90. This is set. Okay, in this set we will retrieve a subset from this set satisfying the given criteria. That is the general operation that we do on the table. Okay, the other operations we are going to look at what are the other kinds of operations that we do, but then generally these are called, basically in the relational model we do what are called set oriented operations. That means we actually do subset, union, intersection. All these operations is what we do. Given this set of tables, this is the kind of thing, this kind of operations that we do on this table are general set oriented operations. For example, what will be a difficult this thing. For example, we'll take another example here. Let us say I have a employee and his manager. Okay, now now let us say employee 101 has 233 as his manager. Okay, and then employee let us say 232 has some 520 as his manager. Okay, now 4, let us say 520 has as a manager some 840. Okay, something like this. There could be other things. Okay, now there could be other entries in this table. I'm just giving you now. Now if you want to say retrieve me all the manager of 101, now what should I do now? First go look at 101, see who is manager, that is 232. Now I have to again go and then check into this table to see what is the what is the who is the manager of 232. Now that is 520. Now I'll again get in and then look at 520 and then get 840. This is basically called navigational query. I'm navigating into this data. Whereas here, if I say get me all the students whose marks are above 60, okay, that is a set oriented query. All the people who have above, for example, I look at the marks column, whoever is above 60, I will return all those rows for me. Here, if I want to now navigate and say who are all the superior bosses of the employee 101, First, I need to go with 101, retrieve this value of 232. Now use 232 again to no, get into this table and get 520. After getting 520, again I have to get 840. This is called a navigational query. Generally, the relational model is not meant for doing the navigational queries. Okay, these are called navigating into the data. You are actually retrieving one, going into the other, again going into the next one. Okay, so basically the relational data model, predominantly the access model, is a set oriented model. For example, if you look at graph databases, generally this becomes more like a graph structure. In the graph structure, the basic operation that you would like to do in the graph database is these navigational queries. One record will point to another record, that will point to another record, that will point to another record. So basically you want to retrieve, after retrieving one record, we call the navigational queries. Predominantly with the relational model, we would like to do set oriented operations. This model is highly suitable for set oriented operations. The minute you want to do navigational queries, you will have extreme level of cost as part of how you want to access this data. Okay. The second part that I want you to understand is relational database models predominantly come with this set oriented operating model or operating access, and this is what we understand as a structured query language, SQL. Okay, relational database generally comes with this set oriented access constructs, access language, which is part of the relational database model, which is called the SQL. Okay, so when you look at a file system access is read write. Okay, you just read any depending on the kind of files that you have, you read one after the other, sequential access of the file. You use the read, fread or fwrite. Okay, fscanf or fprintf in the case of a C program, which I've shown you. That is how the access to the file is. The file higher level access is you read and write into the file. Okay, as opposed to that, in the relational database model, you have a relational model, and the access language is what we call as a set oriented language, which we'll study in detail later. This is also called structured query language or SQL. See, SQL is part of actually accessing the data model, underneath data model that I have. Okay, these two come with me, and I develop now my programs. Instead of developing my programs with files, read and write, I will develop my programs with relational model, where I can store all my data as a relational tables with the access language as an SQL. Now SQL becomes the structured query language, which is a set oriented language, becomes the predominant way of actually going and accessing the data that is there on the system or on the files that I have. Okay, now my programs, instead of being, I can still write it in C language, whatever higher language that I want, but then now instead of the files will be replaced by a relational data model with SQL, and this will be wrapped around by the management system to provide consistency, fault tolerance, and all these other properties I require for this software to be able to develop applications, business applications like banking applications. Okay, right? So this is the first level. You should understand why we need database management systems. Okay, this is the reason why we require database management systems. Okay, then we will develop our applications. Instead of developing with C and Unix files, now we will develop our applications with PHP, C, blah, all that stuff, and database management systems. Predominantly, the database management system that we will use is for business applications, the relational database management systems. Okay, RDBMS with SQL as a language for accessing and then retrieving the data from the database. Okay, right? Any questions? Yes. What is the accessing language for navigational query? Let me go to Vijayanagaram campus. Can I go to Vijayanagaram campus, please? Yes. Are you publishing your video, Vijayanagram? Hello? So there is no video. I think please click on the video wall. Huh? Where is the video wall? I think I'm still not beside the 2D viewer. Huh? Okay, video wall. Yes. Okay. The chat member has quit from there. Do you want to close the chat window? No. I'm still not getting. Yeah, I got it. Yeah. Okay. Yes. Can I get the? It's gone. Yeah. Okay. Who is the student who has asked this question? Who is the? I'm still not getting the. No. Can I get the student who asked the question? Yeah. Can you identify your name?
Sir,
What is your name?
Parvatishwar, sir. Parvatishwar. Parvatishwar.
Parvatishwar. Okay. Good. Yeah. Yeah. Good. Yeah. Your question is what language will I use for navigational queries, right?
No, sir. Is there any difference between? Sir, both, sir. Both the questions. Sir, he has asked, is there any difference between data administration and database administration? And from our side, we have asked, what is the accessing language for navigational queries, sir? Thank you, sir.
Yeah. 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 I think AView actually got into trouble and then it cut me out. Okay. I'm not getting the Vijayanagram. Yeah. I think that is Parvatishwar. Parvatishwar, are you still there? Yeah. What is your question? I'm not seeing your no video still, but that's okay. Can you just repeat your
Yes, sir.
question for me? Yeah. What is your question?
Is there any difference between data administration and database administration? And the is there any
Database?
difference between data administration and database administration? And the second question is, what is the accessing language for navigational queries? He is asking what is the difference between data administration and database administration, if any, exists. Data
Okay.
administration and database administration, are they two different terms or same term?
Okay. See, first thing is, I don't know from where you are asking this question. Where I didn't not talk about the administration part at all so far. I'm only looking at the conceptual part of what is the data model and then how the access works. So I've never used the word neither database administration or data administration. But then, since you have asked the question, okay, this is basically like any operating system needs some administrator to create user accounts, to make sure that access rights are set up for the users. Okay. Similarly, for the database system, you will have an administrator who sets up all the access rights, privileges, user accounts, everything relating to the use of the database management system. And that's what is called a DBA, database administrator. Okay. there is nothing like a data administration. Okay, the data administration means that creation of the data, storing the data, and then retrieving the data. Whatever you do with the data is part of the database system that your programs are manipulating and storing the data back into the system. As far as I'm aware of and I know. Okay. As far as the database administration is concerned, this is like the operating system administrator, the super user that you have for the any operating system, who sets up all the user accounts for access, privileges, everything. Similarly, you will have a database administrator who does all this administration of the database management system for different users who are using the database system. Okay. Second question is that I'm not getting your video. Okay. So the second question that you are asking me is there a language for navigational query? Okay. See, basically you can still do a navigational query using a set. Okay. From what I've actually shown you, you can do a navigational query using a set. Okay. For example, in this particular case, what you will do is, first you will retrieve this tuple. Using 101, you will say retrieve the manager of 101. Once you have got this, now you will again do a set oriented query. Among all these sets, you will retrieve. Every time the set will be returning only one tuple. Okay. Whereas in this particular case, when you say give me all the students who are above 60, you are more or less will return all these tuples. Okay. In the navigational query, each time you will retrieve one tuple and use that tuple again to actually do a set oriented query in the system. So it becomes very inefficient for you when you are actually using the set oriented query language to do navigational query. Okay. Now the question is, do I have a special language for navigational queries? Any query language is connected with the data model that I have. For example, if you're talking about graph databases, it's a different data model. The graph is the data model. Instead of relation being the data model, it will become a graph model. On the graph model, you will suddenly get a navigational query as part of the graph oriented databases. But that's basically a different kind of a data model. But understand, even navigational query can be done using the set oriented queries, but then it becomes very expensive and not very easy to be doing a navigational query using the relational database. That's not what it is meant for. Okay. Right. So that's actually fine. Is that unique? Will it become part of the primary key? And if yes, I think people are jumping the gun. Okay. Okay. So I will not answer the other question right now, other card question, because we have still not reached whether it is primary, what is a primary key and what is a secondary key, what is a foreign key. We have not talked about any of this. So whoever is asking the question has to hold back. He is probably going much ahead and then asking the question, what is a primary key? So that will not be answered at this point of time, because we have still not reached the part of what is the meaning of a primary key and how the primary key will be decided. Okay. So we will not talk about that question here. Okay. Okay. So I think we will get back to the, let me now close the interaction part here. Okay. I think I'll stop the interaction. Okay. Correct. Right. So I'm back here. See, to the extent possible, first understand the basic concepts, then the later parts of it. I'll be happy if your questions are relating to what I'm covering, what I'm trying to teach you. if you're putting advanced questions, I think there's one more question from Jntuk Kakinar. Okay, what is the yes? Is there a question from here? Yes, go ahead. Yeah, please identify your name. Huh? Bharat. Okay, Bharat. Yeah, tell me, Bharat. Huh? I'm not able to hear you properly. Data directly to the table. Huh? Through command line in the SQL directly into the okay. So see, it's partly a question. Have you started working with the database already? Then you should be little careful, because the question that you're asking is, if you want to insert data into the table, you can use a different command for that, and then there is different ways in which the data can be populated into your tables. Okay, different commands for populating your data into the tables. Okay, but all of them come with the indexing. All of that will be created by the DBMS for you when the table data is created. So there is no difference essentially. Once the data is inside the table, whatever way you have actually populated that data into your table, all the related stuff will be done by the DBMS for you. Okay, but there is nothing like directly entering something, because it goes through along with the RDBMS. Okay, right? It provides an interface for you for creating the data into your, creating a table, creating a data. All this will be commands that will be provided by the database management system for you to do that. How are you actually doing with files? There's an editor, right? There's an editor program. For example, I've used the Emacs editor for storing editing the contents of the file. Similarly, the tables, creation of the tables, entering the data into the table, all of that will be our database management system will provide you with the command line interface and different other tools for you to be actually entering, manipulating your data in the database. Okay, we'll see some of this later. Okay, is that all right, Bharat? Or you have, or did I not get your question correctly? Did I not get your question? He seems to be still putting a very no, blank face. Have you understood or you have not understood? You have not understood. What is it that you have not understood? What is it that you have not understood? Huh? Are you getting my screen now? Are you getting my screen? Are you seeing my screen? See, if you look at now this MySQL, this is like the editor, that Emacs. For example, if I am doing that Emacs Bank Master, okay, this is the bank master file, right? When I do this Emacs Bank Master, I'll get this Emacs file where I can enter all this data here, okay, right? Instead of that, now I'll use the database management program called MySQL, okay, and I am the user here. Same way I'm actually logging in like any other. Now I'll go here. Now I am in this. So there are several databases here. This is like the file system, except that here you will have the different databases here. Now I say use RC, change. Now I say show tables. This is like navigating into this. Now I say describe users. Okay, these are all the commands I'll use now. Now I actually want to enter something, edit this table, do something. There is a way I can do this. For example, I want to see what is inside this table. I can say from users. This will give me what are all is inside here. I want to go to some row and edit that row. I will have a command for doing that. Okay. We'll go into deeper aspects of this as we go further. Okay. Right. Is that clear now? Is that clear? So you have to use the database management system that will provide you with all the required tools for you to be entering, manipulating the data, creating the table, everything. Okay. Okay. That's part of the course. You will learn that as part of the course. Okay. Right. Okay. Yeah. Okay. Any other question? Yes. I think it's nice that at least I'm actually interacting with the students so that I know what exactly they're understanding and where exactly the difficulties are. Okay, feel free to ask questions. Don't worry if the interactive part actually will make sure that we are actually changing the course to make sure that you are understanding what we are doing. Okay, right? Now I think the point where I am right now is see. Remember what I'm trying to get you clearly for you. I'm trying to move you from file systems to database management systems. Okay, file systems comes with some tools and then they are done with the programs. Now database management systems will allow you to store the data and manipulate, and there is a management system, and your programs will now interact with this database management system. Okay. I think I'm reaching almost 3:35 now. I'll use the next 10 minutes for interaction. Now, none of the books actually do as I'm doing it from the file system perspective to the database system perspective. Okay, there's a little bit of that available in. If I remember right, I think some of this material is there in the um, um, in the book on Sham Nawate by Sham Nawate. Okay, database management system by Sham Nawate has some little bit of content similar to what I am trying to do in today's class. Okay, but then the most important aspect that I want you to first understand is what is the difference between file systems and database management systems. That is what I am trying to at the first level give you as a difference between file systems and database management systems. That concept should be very clear for you. Okay, right? Now, is there something that I probably would like to give you as an assignment? I will see if in the next class if I can give you a small assignment to make this to get you started with some parts of what I'm actually trying to do. Okay. Okay. So this once this part is clear for you, what I'm going to show you is the management systems part in the next class, and how the end-to-end application will look like when you are using a database management system versus a file system. That will give you all the layers of DBMS: data model, query language, and the database management system, plus the application programming and the user interface. So all these components will come in the database management system, and I'll show you how an end-to-end application gets developed in the database management context, and from that actually I'll show you how this application gets developed and what are the conceptual frameworks that we will use in developing the full-fledged application for the database systems. Okay, and that will take us into ER modeling and relational model. All those further aspects will get built as we are going further in that. Okay, I will be using mainly the book by Hector Gracia Molina, Jeffrey D. Ullman, and Jennifer Wydum. When I get into relational model, RDBMS part, I will largely take it from the database systems, the complete book. Okay, Hector Gracia Molina, Jeffrey Ullman, and Jennifer Wydum. Okay, the first lecture of the NPTEL recorded lecture will add as a supplementary material for today. But then what I have done is much more than what is there in the first lecture on the NPTEL website. Okay, first introductory lecture. Okay, right, yeah, okay. I think I will probably stop here unless you have questions. Okay, I think I'm reaching. Am I actually almost reached the end of the class? I guess so, right? I think it's my time is showing it as 3:37 now. 3:37. Okay, so I think this class should end at 3:40, right? Yeah. Okay. So I think I will come back on Wednesday. The right. Okay. I'm going to log out now. Okay. No questions. We'll log out.